So hello everyone. Sorry for this bit of delay. Every time I have to deal with this cable mess, it's interesting. But also today the project wasn't really working. So anyway, good. So today is Friday, so I'm assuming that you are all done with Lab 0. Is that correct? Yeah. Yeah, the deadline is Friday, 11:59. Is today, right? So those that didn't finish it, please make sure you do so. We have office hours until 2:30, and those that have a lab today, they also get more time with the TAs in the lab session. One piece of advice that I said before, but I want to confirm, is in the submission deadline, which is today, for example, for Lab 0, after 5 p.m. In the past, I've seen that students wait until the last hour and then they try to submit. They face problems, things are not working. Don't leave it for the last hour because I'm not available during that time. I ask TAs basically, they have done their duties. They give you 4 hours every day for support. So if you didn't leverage this, it's out of fairness for them as well. They might not be able to help you, right? But hopefully Lab 0 is just get you introduced to the environment. It went okay. Is there anyone facing any kind of blocking issue that the TAs are not able to help with? As far as I'm hearing from the TAs, everything is under control, and most of you are already done with the lab, right? Also, from what I see from the GitHub classroom for Lab 0 page, I see that there are a lot of submissions. That's absolutely right. Yeah, please.
We didn't have to do any changes for the question each one. Like for the one.
Yeah, that's correct. So in fact, in most of the labs, you will be touching this interface file, and because you are given the code structure, including the interface, and you'll be modifying the actual coding implementation. So most of your changes in almost all labs will be in the C file instead of the header file, unless you are asked to do so. But yeah, that's correct for labs. Yeah. One other thing is that for those that want to start Lab 1, most likely you are going to release the document today as well. Just the TAs are doing the final testing and then we'll release it. For the tutorial, I have already met with the TAs. There has been another confusion for room issues, but from next week, here this thing does not work. Might be a battery issue. Okay, so from coming weeks, everything should be fine. Those that are in front. Yeah, again, it's a battery issue, I think. Okay, a lot of issues today. So those that are in front of me, which means you guys are section 1, right? Your tutorial is always in GHE room. I don't know what is the number, 234, 264. Yeah. So basically, whatever room you see in your mosaic, that's really the room that you should be in the tutorial time every week, and the TAs are aware of this, right? So you shouldn't really worry about this anymore. Good. And you shouldn't also go to the ABB room. This is for the other section. Are you able to hear me well, even without the mic? Is that okay? Try to raise my voice. Good. Yeah, thank you. Okay, so this is more like the logistical stuff. So Lab 1 will start as of Monday, and then it will also take 2 weeks. It's exactly the same process. What you have done in Lab 0, you don't basically need to repeat in Lab 1. You will just be cloning the repository. You already have the environment running. We are all good to go, right? One thing also that I wanted to mention, despite that it doesn't really apply as much for Lab 0, because Lab 0 you need for any lab anyway. But if you decided to MSAF a lab, I already mentioned before in the logistics lecture what is the policy. So you don't need really to email me or the TA asking about this. If you MSAF a lab, you need to forward the MSAF confirmation email to the TA. I also received the confirmation from MSAF. And the policy is for all the C labs, the deadline for submitting the lab is with Lab 3, which is the last lab for C. So you already have the deadline for that. And for C++, it's December 8th, which is the last day in class. Good. What else? If you are an SAS student, in fact, you don't need to send me to ask for extensions for the labs, because my policy is that if you are an SAS student and your confirmation letter gives you more time to continue the work, by default, I give you what I get for the MSAF students. So you have more time to submit the labs. So apply the MSAP policy that I just mentioned to yourself by default. If your letter confirms that you get extra time. Okay, so again, you don't need a confirmation from me as far as you are confirming with the SAS and the letter mentions you need extra time. Is that clear? Is there any question? Okay. So on Wednesday, we started talking about lectures. Well, this went too fast. We started talking about functions. And we have went through the my mean square function. We explained really what happens in memory. So yeah, probably we stopped here. We have seen that every function has three main blocks: the function call, which is the time you use the function. For example, using my mean square in the main, and the prototype of the function, which is the actual signature, the interface, the definition, right? Let's not use the word definition because people use the word definition for the actual implementation, but let's call it prototype or interface. And then this is the actual implementation of the functions. And we also have seen what happens in memories, and then we discussed, well, passing by value doesn't mean that you really update the values A and B when you go to my mean square, but instead you create different variables, different local variables into this function that get what the values copied. For example, the 10 and 20 here, and we have experimented with this last time in online GDP. Everything happens locally within these local variables. The value gets updated in Z, and once the function once the compiler hits or the hardware hits the return value, this one gets be updating in C, and everything else is being destroyed. Right? This is basically what happens behind this. Good. But this also introduced us to some kind of concepts like local variables, right? What are local variables? Global variables, static variables, dynamic variables. So let's see really what does this mean. Live stream. I think it's live stream. Okay, so we have discussed all of this. One thing I have already mentioned, and you guys have seen in Lab 0, is it's always recommended that you split the concern. In programming or in software engineering, this is really called split of concern, right? Or separation of concerns, where you keep the interface in a separate file than the implementation. The interface will always be in the header file. For us, as a function, the interface is your prototype, right? Which is the first line of the function, while the actual implementation or the body of the function will be in the source file. This is what you have seen in the add function, right? Add function in the header file was just the prototype, but then in the implementation, which is question 1.c, you had to implement the actual line that adds the two numbers. Good. And to be able to use this function, you only need to include the header file. For example, in printf scanf, we have used the studio.h. For example, if you write a function, you call it max, then you need to include whatever header file you need. I mentioned before that C standard library has some kind of collections. For example, there is a math.h that has all the prototypes or the functions that are related to math operations. Good. Yeah, here I give you some more examples of the most commonly used header files from the C standard library. We have already seen studio.h. This is for I/O functions, including printf scanf. There is the math.h, which is for math library functions, square root, power, etc. There is also string.h, and we will deal with this a lot when we talk about strings in C. And there is the standard library.h, which has some kind of, well, we'll use it a lot when it comes to pointers, dynamic memory allocation, and some data structures. Good. One note also that I want to mention in this slide is in labs, you are not allowed to use anything from the C standard library unless it's being explicitly mentioned. For example, in lab 1, you will do a lot of math operations. But then, if I don't ask you explicitly in the question or allow you in the question to say you can really use the math.h from the C standard library, then you shouldn't be using any of the predefined functions. So if you need anything, implement it your own. Good. Okay, is that clear? Is there any question? Definitely, if you want to use anything from these, I'm talking generally, not in lab, then we need to include the header file. For example, we have seen a lot that if I use printf scanf, I should really include this. And I guess in one of our very first lectures, if I commented this out, we have seen that the compiler will complain. It tells you that there is an implicit function definition or declaration. And the reason is, well, the compiler will not really know what's printf unless I point to the correct header file. Good. Okay, so here I'm showing you an example from the math where it has square root, cube root, exponential, log 10, etc. Now comes to another important discussion about local variables and global variables. So if you look into this code snippet, I had two variables. One is called by and the other one is called m. I defined m inside the code block. We said before that in C, code blocks are explicitly mentioned by these curly brackets. So here m is only local for the main, which means if I have another function here and I try to print fm, for example, it will not recognize it. Last lecture, we tried to print z, so my mean square inside the main, and well, the compiler complained. Why? Because z was only defined inside the local function called my mean square. Outside of this function scope, z is not being recognized. In our example here, m is only defined in this scope. Outside it, it's not being known, right? Then, on the other hand, by is a global variable. Why? Because it's being defined outside of any of these blocks. So it's not within the scope of the main. It's not within the scope of another function. It's outside of any scope. So variables that are defined outside of any function called global variables. And we will see the differences between them now. So simply, any variable by default defined inside a function is called local, and it's only defined within that scope. And any variable that is defined outside of any function is called global, and it's being recognizable by all the functions in this file. One important code practice is you might think that global variables are really much better to use because I just define my variable once and I'm done. Is that correct? Does anyone object to this? Do you see any side effect? Yeah, please.
If you're given it's a branding.
Exactly. Yeah. Thank you so much. So one side effect is that in fact global variables being global means they stay in the memory for the whole execution of the program. So for every variable in programming in general, and this is a concept that's important to understand away from C, it applies to anything, Python or any other language. For any variable, there's something called scope, and there is something called lifetime. Good. Scope is within the code range where the compiler recognizes, the hardware recognizes this variable. And for the scope, we differentiated between local and global. We mentioned that m is only defined here, while by is defined everywhere in this file. This is scope, right? But lifetime, which concerns really the drawback that your friend here said, global variables, because they are recognized everywhere, so they should stay alive, recognizable, as far as you are executing this program. So they stay more in the memory, right? On the other hand, local variables, we have seen last time in the example that I have shown you in for the my mean square, once you go out of, so x and y and z get defined, once you jump into my mean square function, allocated in the memory, but once you return, they get destroyed. We said this last time, right? So they no longer exist in the memory. So you don't occupy space in the memory unless you really need it, right? And once the need has gone, well, this memory has been deallocated and you can use it for something else. If I define everything as global, well, global, I need it everywhere, so I cannot really remove it based on a function call or function return. So the more you add global variables, the more these variables will be in the memory, and then you keep accumulating. So if you are programming something like Arduino or something with very limited memory capacity, well, you will spill out of memory and you will get a problem, right? So you should minimize using global variables as much as you can. This is one drawback. What is the second drawback? Can you think of something else that might be a problem? Yes.
I have a question.
Yeah, sure.
So when does it ever become more efficient to use a global variable? Like if you're like defining like a variable like multiple times, or like does a global variable like always take everything?
That's a good question. So what I'm saying, it's a good programming practice to limit the use of global variables as much as you can. Does it mean that for a certain use case, global variable cannot really be more efficient? Yeah, there are cases where global variables are really fundamental, needed. But the point is that try to give it a second thought. Well, I would say 90% of production code that I have seen, that if you think at the beginning that yes, global variable is my way to go, there might be more better ways that you can really use other than global variables. So you should give it a second thought. Because, well, for example, if I want to pass something from a function to a function, well, pass it as an input parameter, output parameter. In that case, you have a clear interface. Because the second drawback that I was looking for, maybe I shouldn't answer, but yeah, sure.
Isn't that like if you change the global variable, you're changing it for like all the functions?
Exactly. That's the point. Is that global variables are risky because local variables, if they have a bug, it's local to their own behavior. So again, it allows for debugging, ease of debugging, and clean interface. But global variables, if you change the y value, it changes everywhere. Maybe you want to change it for some place, but some place not. Another reason that makes it problematic is that here you break any interface. If this variable becomes clear for everyone, for example, if you have something called x as a global, but and then, well, you are working on maybe a project that has 10 persons or 10 engineers. I define a global variable called x. My friend doesn't know really what I'm doing here. So inside his function, he's going to define another variable called x. Once you go inside this function, now there are two variables called x. One of them is global, the other one is local. Which one takes precedence? Which one really means what? It becomes very problematic, right? So again, you break the interface. So you should go away from global variables as much as you can. But learning about them is important because also if you have projects that already have global variables, how to debug them. Good. Okay. So something that we put as a general rule is let's not really use global variables at all. And this is a way to train you a little bit on having a good programming premise. Okay. So here we have an example where we are using both global variables and local variables. Can someone highlight where is the global variable here? Well, it's already mentioned in the comment. So alpha is global. And the reason is I'm defining it outside of any scope. I'm putting it in the same range as I'm putting a prototype of a function called square, right? While a, for example, is a local variable because a is only defined inside the main. Now what I'm trying to do is I'm defining a function called square where it takes it takes no input here, and we'll say why. But then it returns the square of this alpha thing. So the reason that this takes void is in fact it's squaring the global variable itself, right? So you don't need to pass anything into it. Is this the good programming practice? In fact, this is a bad program, right? And the reason is if you want really to square alpha, right now this square only works for alpha, it doesn't work for something else, right? If, for example, you want to square a different value, you have to modify the code. You have to hard code it to modify alpha to something else, right? Despite really having something dynamic that takes any input parameter from the main. Okay, so if I go inside the main, I say a equals square, and I pass nothing, it's going to square alpha, so it's going to be 1.5 square. And then I try to print a, well, it worked completely fine, right? Because I have no problem at all. But if I have another version of the program where alpha is only local to main, so I have something like this. I define, well, nothing changed in this whole program other than taking this line, put it inside the main, right? You see that? So simply the only change we have is we took this. This was fine. If I take this, yeah, that's because of the slideshow from Teams. I'm not able to see exactly what you see. Let me see. So it's slideshow. Okay, if I try this now. Yeah, everything is saying that right today is not working. That's not my day. Okay, so simply this line here, I have taken a put inside the main. What is the implication of this? What do you think? Well, again, it's being written here, right? If I try to execute the same function, this alpha is not recognized. Why? Because it's a local variable to me. So if you try this program, you will get a compile error. Tells you, well, alpha is being used without being declared. Right? Makes sense? So we have already discussed the scope thing. So there are like 4 types of scopes in C. There is what we call file scope. So if you have a global variable, it's being defined for all the functions in this file. For example, alpha, in our earlier program, it has been recognized by the main and the square and any other function that is inside this file. We have what we call block scope, which is by default the local variable scope. Where do you define this local variable? It's being defined inside. For example, if I define a variable inside the for loop, I cannot use it outside, right? Because it's only within that block. A local variable gets defined within the block of the loop. And the block for C is, in fact, explicit by the curly brackets. Good. And then function scope, if you have something like, basically you define something like a switch statement or something inside a function, it's not being recognized otherwise. And then the prototype scope, which are the input parameters you pass in, right? So something, if you think this is a little bit problematic, in fact, you can think of these 3 types or confusing. If you think about these 3 scopes here, they are all local scopes, right? So the big difference is between these 3 and the file scope or the global scope.